Okay, good morning everyone. Thank you for joining us today for our Future-Proof Wonderware webinar series. Welcome to our Quality Operations Management for the Plant Floor webinar. And today we're going to be looking at helping to improve operational excellence, regulatory compliance and product safety. So what I'm going to do is mute everyone's lines initially for the presentation, and I'll unmute them at the end and take any questions. So I'll mute the lines now.
Participant lines muted.
Great, okay, well, we'll begin. If you have any questions, like I say, please save them till the end and I'll unmute the lines. This webinar is being recorded and will be placed on our website later today, so feel free to share this with any colleagues. Today the webinar is being hosted by Chris Jackson. He's our Senior Technical Consultant here at Wonderware UK and Ireland. Chris has actually worked for Solutions PT for over 19 years and specialises in InTouch, Historian, System Platform and Wonderware MES modules. So good morning, Chris.
Hello.
Hi, if you'd like to begin, that would be great. Thank you.
Hey, thanks, Sarah. In this webinar, if I can get it to move on, okay. In this webinar, we're looking at Wonderware MES Software in general and the quality module in particular. The current release of the Wonderware MES Software is 2012, and the primary focus of that release was the introduction of the quality module to enhance the existing operations and performance management capabilities of the MES software package. The purpose of the quality module is to provide quality specification and sample management in a work order execution context, and in addition support statistical process control monitoring and reporting of the data being sampled. When we look at the requirements of a quality management system, then you're obviously looking to be able to define the test parameters, the schedule at which you want to perform the quality tests, what information you want to actually capture, record the execution, make sure that the data is collected at the right time by the right people, and then obviously managing the analysis of the data after the event. So the quality management module complements any enterprise level quality management system that you may have by providing the automation of the quality operations execution on the shop floor. The benefits we're aiming to achieve by using this quality management module is, first of all, being able to increase your operational efficiency and have improved accuracy of the data that's being collected for quality purposes, and overall to reduce the cost of the quality management system. So removing paper trails, doing things automatically as far as possible. Secondly, to provide a higher operational agility, so that as your production schedule changes and you're making different products at different times, obviously the quality parameters that you want to collect will depend on what it is you're manufacturing at a particular time. So being able to easily switch between different quality plans of what you're trying to collect means that you're going to meet the customer requirements for compliance and also product safety. And finally, it's all about improving the product quality of the products that you're manufacturing. Additionally, trying to reduce losses through having a tighter control of your quality system and be able to respond quickly to non-conformances or deviations so that operators can take the necessary actions to correct any of those non-conformances or deviations. If we look at the capabilities within the quality module, first of all the quality specifications, where you're defining the quality specifications in terms of the products that you're manufacturing, the equipment that you're using, and the operations performed on those equipments. Secondly, there's the sample plan definition, and here you're defining what it is that you wanted to collect, so the individual characteristics that need to be measured, how often the samples should be generated and collected, and providing information to the operator for that sample plan. The sample plan execution can ideally be automatic, so that if you have the relevant information available from your automation control layer, then the individual characteristic sample values can be collected automatically and stored in the database. Alternatively, if that information is not available from the automation system, then we have the ability to prompt the operator for when samples are due and lead him through what characteristics need to be measured and allow him to enter those values through the HMI screen. The statistical process control component allows us to monitor the quality data and look for violation of SPC rules and notify operators appropriately so they can take the necessary action. Finally, the work order execution component means that we're able to track the status of work orders in a dynamic sense so that we can make sure the correct quality specification rules are applied to ensure that the right data is being collected for the products that you're making. The quality module within the Wonderware MES software is built on the ArchestrA System Platform, and that provides us an infrastructure for not only supporting the execution of these MES functions, but also the integration with the automation equipment through the legendary Wonderware interconnectivity to a variety of PLCs and other automation equipment. There's also the integration of the manufacturing operations management system with the process management or supervisory control layers in the ISA model levels 2 and 3. And finally, the management of reporting and supply of information to the relevant users through a web interface via information server. So let's look at quality specification management and what it would mean on the shop floor. So if Joe operator on the shop floor starts a new job on the production line, then the system will automatically look up, based on the information for that work order, what products are being produced, which manufacturing operation will be executed, and what equipment is to be used. Based on those parameters, a sample plan will be generated to provide the information for what needs to be collected for the manufacture of a particular product, in this case a blueberry cupcake. And so that sample plan is made available to the operator on the shop floor to guide him through what is required from a quality perspective to make sure that the correct data is captured. So the benefits of having this approach for quality specification management is first of all ensuring that according to the specification and tracking of the current work order execution status means that you are ensuring that you are collecting the correct data and complying with customer requirements for quality parameters. Being able to cope with schedule changes, so there might be a planned work schedule but that needs to be altered because of the situation on the plant floor. So although you are planning to make a particular product, you decide to switch to a different work order and make something else. Obviously the quality system has to respond to that and make sure that the correct data is collected. And this is going to allow you a better schedule agility and flexibility, and it means the operators don't have to worry so much about ensuring that they are keeping track of what needs to be done, because we're leading the operator through and providing him with prompts of what needs to be collected at a particular time. So this is trying to avoid operator error and make his job easier to do. So the sample plan that's generated will contain details of the characteristics that need to be measured. So it might be bricks or pH or whatever it is. The sample size, so for a particular sample reading there might be a number of separate measurements that have to be made, and then you would take an average of those measurements as being the overall sample value. And finally, the frequency at which the samples are to be generated. So this might be simply on a time basis, so you want to take a quality sample every hour, or it might be, say, that you do it 4 times during a shift, or it might be associated with the actual work order. So as soon as you start the work order, you do a quality sample. You need to do one just before completion and 2 or 3 times during the execution. So the sample frequency determines when data has to be collected. So based on the current work order status, the software will, if available from the automation level, automatically collect the quality data at the correct time for the samples as they become due. And obviously that sample data and the associated work order context is stored in the database. Alternatively, if the information is not available from the automation layer, then we have the ability of prompting the operator when a sample is due, so that he can see on his screen, okay, it's now time to enter, say, the weight of the cupcake sample, so he knows what needs to be measured, and then allow him to actually enter the results through the HMI screen. So the benefits of this approach: obviously, if we can have automated data sampling because the information is available from the automation layer, we're reducing the cost of supporting this quality management system. And that would give you tighter quality control because you know that the data is being collected at the correct time, because it's collected automatically, and you have that elimination of response delay time in terms of relying on the operator doing the collection. Alternatively, the electronic procedure management, through prompting the operator when to take errors, when to take measurements, will reduce the errors and efforts associated with the quality operations, and should improve your overall operational efficiency. And because we've got a higher accuracy of the quality data, that should vastly improve our compliance to customer requirements and give you a better audit trail of what the quality parameters were through the production process. If we look at the SPC aspects of the quality module, what we're saying is that the sample data that you are collecting can be instantly monitored for quality control. So that can be via SPC charts and trends, so that the operator can see how the production process is performing over time, and through the chart or the trend, he's got an immediate visual indication of how things are going, or indeed the sample viewer allows him to look at the values which have been collected either automatically by the system or manually via the operator. And obviously, since we are doing SPC control on the quality system, then any violation of SPC rules or specification limits can give us notifications to the operator to bring his attention to the fact that the system is going out of control and get him to take the appropriate remedial actions to bring it back within control. And finally, of course, all that data that's being collected in the database can be amalgamated into reports, which we can then present to the relevant interested parties, the laboratory technicians or the production management, whichever department needs to gain access to the quality information, simply by using Internet Explorer to access information through a web interface. So the benefits of having this statistical process control capability within the quality management module is essentially to reduce our quality losses and be able to respond quickly to any deviations from the target quality parameters. And the operators will be notified in real near time of any non-conformances or limit violations that occur, so that they can take the appropriate corrective actions. And the statistical control rules would allow operators to take preventative actions, even to avoid a non-conformance before it appears. For example, one of the SPC rules that you might apply is that 5 consecutive readings in a row are all increasing in value. So that might be an alert that you want to bring to the operator's attention so that he is warned in advance that the system seems to be going out of control, and to make the necessary corrective adjustments to the system to bring it back in control. If we're looking at integration to higher level systems, then all the sample data that we have been collecting can be either pushed to or pulled from those other quality management systems, and the sample data supplied obviously has this rich work order detail context. And the data transfer can be via the Wonderware Enterprise Integrator software, or indeed just through shared database tables, or even using application programming interfaces such as iDocs and BAPIs in the SAP world, or indeed there is an application program interface library provided for the MES software itself for extracting data from the database. And the sorts of external systems that you might be supplying this quality data to would be laboratory information management systems, perhaps standalone quality management systems, or even quality management modules within ERP systems. We look at the components that are supplied with the quality module software. First of all, we have a .NET control, which is the sample viewer control. And this we can build into the operator HMI to prompt the operator when samples are due, and also give him forewarning of when samples will be required in the future. This is obviously for a manual data collection system, whereby by expanding the sample data, he can see exactly which characteristics require measurement, and then provide facilities for entering the data in as he takes the measurements. Alternatively, if the information is being collected automatically by the system, they will still appear in the sample viewer control, and so the operator can review what values have actually been measured through the production process. You can then select any characteristic and immediately get the current SPC chart and look at the trend of how the measurements are varying over time. So you can immediately see whether the process is performing correctly or whether it's drifting out of spec. We also have a .NET control for displaying the SPC Control Charts for any selected characteristic. So here you might provide a full-page display where you can look at all the quality measurements and scroll through the available data and see the associated distribution chart, which ideally should be a normal distribution if your process is in control. Obviously, if it's skewed one way or another, that's cause for concern. Where you have limit violations or out of specifications or SPC rule violations, they will be highlighted as red dots on the graph, and the operator can then get information about what rule was violated. And then we have a sample recording object, which is an additional template object which is included within the system platform application server environment to enable two-way communication between the user and the Wonderware MES database through the MES middleware. So this allows us to do the automatic recording of data for the various characteristics which comprise the sample of information that you're trying to collect, and also allows you to apply contextual information either to the sample as a whole or individual characteristics within a sample. And then finally, there are out-of-the-box reports provided with information server. So, for example, the Quality Management Summary Report would give you details about which characteristics are giving the most problems. For example, the percentage of out of specifications here. And that obviously will drive you towards addressing those particular areas which are giving you the most cause for concern. That information is viewable either as a Pareto chart or as summary data in a grid, or individual measurements which comprise the data. The characteristic detail report allows us to provide SPC chart information in a report form so that people in the management departments can see how the quality parameters are varying over time. And again, the full detail of the actual measurements are available in tabular form. So what I'd like to do now is to switch to a demonstration environment and give you a brief view of what the system would look like. So here, for example, we have the sample viewer, which is color-coded to show which samples have been completed. Those are coloured blue. Which ones are due, they will be coloured grey, and which ones will be coming up shortly in white. I might need to refresh this display because obviously time has moved on and additional information has been captured. So you can see that there are a number of samples here which are already due for this particular sample plan. And if I click on the plus next to it, you'll see the characteristics that need to be collected for that sample. In this case, only one, which is the appearance. So by using the button bar at the bottom, I can collect information for that appearance, and I get a data entry dialog box which lists the characteristics that need to be collected and allows me to enter the results. In this case, we're looking at examining a number of sampled items and saying which ones are meeting the quality requirements of the appearance of the product and which are failed. So we can say that in this case, say there are no non-conformances for this particular sample. And if we save and close that, then that particular sample will then be coded blue, and we should see that the result is shown as good. So now it has a refresh to show that that is now complete. If we have problems occurring in samples, so these sample plans down here for the liquid and the regular, these are sample plans where the data is being collected automatically. So if I was to select one of these samples, then I can see the actual characteristic values in the lower window. So in this case, I'm measuring density and turbidity, and each of those characteristics requires 10 separate measurements to be taken. And we can see that a lot of the measurements are out of specification, therefore coloured red, and only one density measurement there of the 18.93 is actually okay. So the colour coding immediately gives the operator information about how things are working. If we look at the critical sample, for example, here we're collecting moisture and solids, and we can see that the moisture characteristic is the one that's giving us problems. So if we wanted to look at the associated chart for that particular characteristic, we could open the sample, select the turbidity, and say, let's see how the SPC parameters are varying over time. So this immediately gives us an indication of how that particular measurement is performing and tell us whether the process is in control or not. Alternatively, you might want to have the chart as a full screen display and be able to select the characteristic of interest from an available list. So here I could look at, say, the moisture, and that shows me the trend over time and where I have problems. So I can see I've got an alarm indication here. So the problem was that there was a basic rule number 2 violation, and obviously the SPC rule is whatever you have configured for this particular characteristic in the sample plan. The operator can also add notes should he wish. So if corrective action has been taken, then you could enter that as a note field, and then that obviously will be available for other people to see in the future. by just clicking on the relevant part of the screen. So hopefully that's given you a brief overview of what the system capabilities are. So I just need to go out of that and then come back to my presentation. So if we're looking at the MES system as a whole, then you would typically need to have connectivity to external systems, such as other supply chain management modules or ERP systems. And the Wonderware Enterprise Integrator is what we would generally use to provide that connectivity. If we look at the functional requirements of an MES system as defined by the MES International body, then these are the sorts of functionalities that are required, like track and trace and genealogy, managing your processes, doing data collection, management of labour and so forth. All of these functional points are covered by the Operations Management module of the MES software. Performance analysis requirements are handled by the Performance Management component, and this allows you to monitor utilisation of equipment and do OEE calculations. The quality management requirements, obviously handled by the Quality Management module, which we've just been looking at. And the final functional point, which you'd expect to see in an MES system, of maintenance management, is not actually covered by the Wonderware MES software, but would be covered by, for example, Avantis from Wonderware, or indeed lots of customers have their own maintenance management programs, such as, the name escapes me, I've forgotten in just a moment. And then obviously you need connectivity to the control system, so the automation layer, to provide us with the real-time information to support that MES environment. And that's provided by a system platform, which also provides us the infrastructure for supporting all those MES capabilities. In addition, we have higher level functionality systems such as ArchestrA Workflow. So this allows us to define a workflow to handle situations which may occur in the plant. For example, there might be a major quality problem on the system which would require the lab technicians to be informed, for the planning department to be informed, for the lot being produced to be automatically placed into quarantine. The lab technicians would then need to do some quality analysis on the product to see whether it can be released to the customer or not. And all of these steps in the process can be monitored and controlled by a workflow system. We have Wonderware Mobile Solutions, which allows us to monitor and capture information onto mobile devices, and that's supported by, for example, IntelliTrack from Wonderware. And then Wonderware Intelligence, which provides us with high-level data mining and data analysis capabilities, where we can look at the correlation of data not only within the MES database, but also, say, your alarm database, the historian database, other ERP databases, and provide reports based on the correlation of information between those various data sources. So we're looking at the value proposition of such an MES system or manufacturing operations management system, being able to take advantage of the automation available and capturing information automatically, providing that operational efficiency, agility in being able to keep track of changes in the works order schedule, ensuring compliance to customer requirements for quality measurements, and giving you a higher visibility within the supply chain in a real-time sense. Now, when you install the Wonderware MES software, you have access to all those functional points which we were looking at in the previous slide, and the various capabilities are simply enabled through purchasing the relevant license. So, for example, a quality license would enable all the quality components in the quality module. The work order execution component actually being a common module which is applicable to all of the components within the MES software, because you always need to have the work order context for whatever it is that you are looking at. So, for example, the operations license would enable all the functionality concerned with track and trace, bill of materials, genealogy, inventory tracking, and so on. And it also needs work order execution to associate those operations with specific work orders. And finally, the performance license would enable the components to enable you to do utilization calculations for equipment, capture downtime events, and do OEE calculations. So we're looking at the benefits of the various MES components. The performance component is designed to enable you to identify where your most productive assets are, so that you can use those in preference to the less productive assets to reduce your capital expenditures. Identify bottlenecks in the production environment so that you can improve your asset utilization. Pinpoint the downtimes which are occurring, and through a quality improvement program, reduce those downtime events and thus increase the capacity of your assets. And by doing comparisons line to line or plant to plant, looking at OEE measures, then leveraging best practices to ensure that you are getting the best out of the various shift teams or lines in your operation. And finally, empowering operators by providing KPI information on the HMI screen so that they can take action to improve the production performance. If we look at the operations module, then we're looking at providing production execution information in real time, so capturing what's actually happening in the production environment and improving your manufacturing agility. By enforcing electronic manufacturing procedures, by defining a model of how you actually make a product in terms of the process, the operators, the equipment and materials involved, then we're looking at consistent production, so you always make the product to the same quality standards over and over again. Collecting the production routing history, labour history and material usage history, we're looking at track and trace manufacturing genealogy. As we've seen from recent reports in the press, being able to identify exactly what's gone into the product that you're making is extremely important. And finally, providing real-time order, material, equipment and labour status, so you know exactly what's happening in real time on the production floor. You can improve the decision support and planning within the supply chain. And finally, the quality module, we're looking at the automation of quality sampling procedures where that data is available from the automation layer, or leading the operator through a defined set of sampling procedures, telling them what needs to be sampled and when, so that we're increasing the operational efficiency of maintaining quality within the production environment. It should give us an improved accuracy of the quality data and able to reduce the cost of our quality management support. Having this capability of handling dynamic, ever-changing production schedules and ensuring that the correct sampling plans are used at any particular moment to capture the correct data means that you are improving your operational agility and making sure that you are collecting the correct data to comply with end-user requirements. And finally, by incorporating SPC monitoring, it enables us to improve product quality and reduce losses by having a tighter control over our quality parameters and being able to respond to non-conformances or deviations as they occur and take the necessary corrective actions in good time. So in summary, for the MES software package as a whole, it's a granular approach where we have these three available modules which are enabled through licensing. So it enables us to avoid the big bang approach and do a step-by-step implementation where you might start with a pilot scheme and look at one particular production line, prove that the software provides you the benefits that you're looking for before rolling it out onto subsequent lines. We're talking about configuration here rather than cutting code, and it's very easy to quickly put in the customer requirements that are required to reflect the production environment for a particular customer. And the flexible approach that we have enables us to increase the scope and size of a project over time very easily. And because it's all built on the ArchestrA System Platform as the environment in which it runs, then we're taking advantage of the incredibly good connectivity to the shop floor to gain access to the automation information. The object approach to System Platform enables us to derive standards for use throughout the organization. So if you're talking about being able to do production in the same manner across multiple plants, you can do that by using your standard objects. And finally, having this reporting services layer, providing information and reports through a web interface for anybody who needs access to that production information just using Internet Explorer. So hopefully that's given you a good overview of what the Wonderware MES software is all about, and the quality module in particular. And so if there are any questions, I'd like to open the lines now and respond to anything you need.
Participant lines are muted.
Thank you very much, Chris. Any questions?
Yes, Mike, carry on. Sorry, Mike. Hold on a minute, Mike. We've got very bad feedback here. Sorry, Mike, we've got terrible feedback on the line here, and you were quite faint, so I wasn't able to catch the question. Would it be possible for you to type the question in? Does anybody else have any questions at the moment? While
Can you hear me here?
We can hear you.
Mike, can you hear us here? I can't hear you. Yeah, it's good already here on G. The question there, I was wondering if you could enlarge a little bit more on the sample recording object, the SRO.
yes, what would you like to know? The SRO is where you define. The SRO is where you define what task plans you're going to use and what characteristics you want to collect and where the automation information is coming from, so attributes of another object that will provide the actual sample values that you want to record. So by configuring the SRO in what samples need to be collected, what characteristics, then that sampling can be done automatically through the automation layer.
Okay, Mike, thank you. Thanks for that, Mike.
Okay.
Any other questions?
Do you have any questions?
Okay, well, if there's no more questions, thank you very much, Chris, for all the information. And thank you, everyone, for attending.
one last question here.
Yes, go
Is
ahead.
it possible to get a copy of your application sent on to us?
A copy of the
The
application.
presentation.
The presentation certainly we can make available.
Copy of your presentation.
Yes, certainly.
Pardon?
Certainly we can do that. Will we post it on the website, will it?
Yeah, the webinar's been recorded, and the recording will be posted on the website, so you actually will be able to download it yourself this afternoon, if that's helpful, or we can also send it to you as well as a PDF presentation.
Yeah, if you could do that, it would be appreciated.
Okay, that's no problem. Yeah, I'll do that. Any more questions for Chris?
Any more for Chris? Not all right here, folks. No, thank you.
Alright, that's brilliant. Well, thank you for attending. It's just worth noting that our next webinar is on Web-Enabled Alarm Management, or WAM, which helps you to prioritise your alarms, and that's going to be on the 11th of April. And the webinar after that is about reducing the cost of energy consumption in manufacturing, and that's on the 17th of April. So it would be great to see you guys if you're interested to register using the Wonderware UK or the Wonderware Ireland website registration pages. Well, thank you all for attending. Thank you very much, Chris. That's great. Thank you. Bye now.
Thank you, Chris, and good night. Bye-bye.
Bye-bye.
Very good.
Hold on. So let's stop the recording.
What was my question? When did we work that out?
Who asked that question?